Hi guys, today let's discuss graphical interpretation. Now, graphical interpretation questions are kind of dependable. They are a little easier along with table analysis, at least in the data insight section. And the other questions, your MSR and two-part analysis, as we discussed last time, are kind of hard. DS also, sometimes it can be a little hard, but then normally, in case you are careful in graphical interpretation, then they're not very tricky. You would normally get the correct answer in these. Of course, there are lots of different types of graphs that can be tested in graphical interpretation questions. Your bar graphs and pie charts, of course, line graphs, scatter plot, etc. Right? We have discussed all these in the graphical interpretation module, so I'll not repeat that today. But there are three types of graphs which can be slightly tricky. So I would like to take those. Now, one, as we have discussed already in our graphical interpretation module, the which can get really a little difficult is that cumulative line graph, because you have to take care of the slope and that gives you the increase, and you have to see whether the slope is steep or whether it is not very, or maybe it's flat, that means there is no increase, etc. So you have to focus on that, which is not very intuitive in graphical interpretation questions, and that is the reason why we discuss that in detail in our module, in the video. So today we are going to discuss the two other types of graphs which can be slightly tricky. One of them is your bubble chart. Now, not because there are any kind of traps or pitfalls there, but because it's a little harder to understand. So that is why we'll spend some time on a bubble chart, and we'll also look at pi in pi. Again, the graph is not tricky. It's fairly simple. The only issue is that it does involve a good understanding of your percentages. And in case, that is not very clear, then the chart can get a little tricky. So we are going to take a look at that as well. Those two are pretty much, two of the toughest that we have in our question set as well. So now these two sets are going to be from our own content. Yeah. So we'll discuss these today. Okay, now before we start, just one point, the most important thing in graphical interpretation, you have to focus on what is given on the x-axis and what is given on the y-axis, right? Be very careful about, the interval, what exactly is given, and then same thing about y-axis also. If you read the data correctly, which only requires your complete focus and not much else. If you read the data properly, then already half the battle is won. Then, there isn't a whole lot to do. I mean, then it becomes relatively simple. Just that you have to be careful while taking the reading in graphical interpretation. Yeah. Okay, so let me share my screen and then we'll start with some questions. So here is my screen. I hope you can see it. In case there are any problems, your Q&A is enabled. So let me know in case you're unable to see the screen or something. Here on the left hand side, I have the question and I have the graph. Here, as in the question stem and the graph. And here I'll give you the questions one by one. We'll discuss them. And of course, this is my scratch pad. So let's first go through this question, understand what the graph is giving us, and then we look at the questions. Yeah. All right. So in the survey, people were asked what one activity they like. All right. Okay. Now, before we start with this question, let me do another thing. I will tell you about normal type of pi and pi, a simpler pi and pi that we often see as well. And this question is going to be a little different from that pi and pi. So the one that we see sometimes is, let's say this is your pi graph. Yeah, so that's it. Whatever, it looks something like this. And these are the various sections of the pie chart. Yeah. Now it is possible, let's say this is your 10%. It is possible that this is further divided. Let's say this is your 1%. This is, this represents, let's say, a particular company. Yeah, let's say a company A. And then this could be, for example, if you're talking about the revenue, for example, this could be the revenue of the various divisions in company A. So let's say there are 4 of them, and the revenue of this is 1%, revenue of another division is 2%, another is 3%, another is 4%, for example. Yeah. Now, but this is not a true pie in pie graph, right? This is just this particular part, which is divided into 4 different parts, right? I could very well divide this chart as it is into, and this part into, let's say, 4 parts, right? It becomes very difficult to mark there, to label this diagram. Those parts are really small, so that is why it can get really confusing. And that is why sometimes the data of one particular part is represented in separate diagram. Yeah. But then these percentages are just adding up to 10. So if this entire section is simply 10%, you see these percentages are simply adding up to 10. So then we handle it exactly the way we would handle any other. Let's say if this is 20%. Whatever we would do with this section is exactly what we would do with this section also over here, right? This is just a much smaller part of the pie, but nevertheless, this and this and this and this, they are a part of the same pie, right? All right. But then this question, the one that we're going to discuss now, is a little different. So let's look at that now. Okay, in a survey, people were asked what one activity they like. The data obtained is expressed as the all activities pie chart below. So do we see this pie chart, the top one, all activities? And people were asked what one activity they liked. And of course, all these percentages would add up to be 100. We don't even need to confirm it. Of course, it's a pie chart, right? They'll all add up to 100. And then you have the football, cricket, etc. Now, it's blue. The football is represented by a blue part. Of course, there is another blue. Dancing is also blue, and there are 2 blue. And in case you're getting a little confused which one it is, don't worry, start in sequence. Look, it's this blue seems to be this blue, right? Football. Next is cricket. I do see this is orange. Next in line is gray, the 8%. Yeah, it is. Next in line is hockey, which is 8%. Then yellow painting. Yeah. So this all adds up. So I know that it is starting from this football is my 14%, cricket is my 24%, etc. and so on and so forth. Right. Okay. Now the ones who answered indoor games, where is indoor games? Here is indoor games. We see, all right. The last one, this 8% is the indoor games, right? The ones who answered indoor games were further asked to select one of the indoor games, and the responses are captured in the indoor games pie chart. So then what we have is we have another pie chart, which is called indoor games. So this pie chart represents this particular section. You see this 8% section, this entire 100, this is again a total of 100, right? Again, various activities captured to give 100. So this is this small section is actually including all this. Yeah, this pie chart is a subsection of this particular pie chart. Yeah, this entire thing is 8% of this pie chart, right? This is just the indoor games. And then you start with Monopoly, and then comes the orange, so that is chess, and then of course the gray, which is Jenga, etc. Right? Now, all numbers in the pie chart are exact values. Now, why have we been given this? That these are not approximations, right? These are the exact values. So over here, for example, if there were, let's say, then can I say, people were surveyed, right? So then can I say that, okay, if 100 people were surveyed, no issues, there were 21 people who said that they like music, there were 8% who said they like, 8, then they said that they like indoor games, 14 said they like football, etc., etc. That's fine. But can I have 50 people who were surveyed instead? Can I say that, okay, 50 people were surveyed? Is that okay? Think about it once. Then if I'm saying that 19% people said painting, yeah, then does that work out? can I say that if there are 50 people, then think about this. Let's say, if I say, okay, 19% of 50, these are the people who liked painting. Is that possible? Think about it. When I have 2 over here, what do I get here? I get a 9.5. Is it possible that 9.5 people liked painting? No, right? Basically, I'm saying, when I'm saying these are exact values, nothing is rounded over here. There are no decimals over here, right? Which were rounded to give these. So then I should ensure that there are integer number of people for each one of these sections. Yeah, this is the only important part about this whole question. This is where all the complication comes in. Yeah. Okay, based on these charts, answer the questions given below. All right, so now let me just first get rid of this. All right. So then I hope you've understood what the chart gives us. Here are the two pie charts. One is the all activities, the other is the indoor games, which actually represents this particular 8%. Yeah. All right. So now let me share a question with you. You take a couple of minutes and then we solve it together. Let's do it together now. Yeah. The number of people surveyed. So essentially over here, right, they must have been at least. All right. Now, we did discuss before, and I did point out this prime number that is then 19%. So then the number of people has to be at least 100, because 19% of which smallest number is going to give me an integer. If I say 19% of which number will give me integer, well, this, if I'm looking for the smallest number, this has to be 100, right? It cannot be anything less than 100. If I have a 50, then my denominator, I have to cancel off the entire denominator to get the integer, right? And then in case I don't have 100 over here, there is nothing that will get cancelled off from here. So then if I have, let's say, just a 50 over here, it will not get fully cancelled off. So I will not get an integer. So on that logic, we discussed that, okay, this has to be at least 100. All right, great. So now then is 100 my answer? So think about it. I have to ensure that whatever is the minimum value, that has to be valid for the entire given data, right? For both all activities and indoor games, it should be possible. So now what if 100 people were surveyed? Okay, then 8 of them liked indoor games. We're good with that, right? All the others will, of course, work out. We have no decimals anywhere. So all the others will work out. Or everything else will give me an integer. Now, indoor games, it means that there are 8 people who liked indoor games. Now, let's come to the indoor games chart. Yeah. So 10% of the people who liked indoor games said that they like Twister, right? So I say, okay, so 10% of 8, these people liked Twister, but that gives me a 0.8. Now, I can't have 0.8 people. It has to be an integer, right? Number of people has to be an integer. And everything over here is an exact value. There are, as we said, that everything is exact. So we're not rounding up, we're not rounding down. There is nothing of that sort going on. So when I said 10% people, then that 10% has to be an integer. Well, this is not an integer, right? So then this doesn't work, correct? So my 100 is not the answer. All right, let's look at 625. Let me look at 625 number of people surveyed. All right. Now, again, let me come to the 19%. It's the easiest, right? It's a prime number. I don't have to do any other calculations. So I'll say 19% of my 625. Yeah, this should give me an integer. Will it? Do I really need to calculate it all? One thing I can see that this is odd. Of course, the prime number, it is odd. This is also odd. This is my even number. So it will certainly not give me an integer. Yeah. Alternatively, even if that thing doesn't strike, doesn't matter. What is 625? It's a 5 into 5 into 5 into 5. I know this. I should know this for sure. Yeah. What is 100? 100 is 5 into 5 into 2 into 2. Right? My 5s do get cancelled. But what about the 2 and 2? I don't have any 2's here, right? Of course, this is a prime number. It doesn't have a 2 at all. Then what? Then will this thing give me an integer? The 19% of 625? It'll not give me an integer, right? So again, the 625 is not possible, which of course leaves me with 2500. So I know that the answer must be 2500. I say that the number of people must have been at least 2500, and I mark the answer and I move on. Obviously, I don't worry about anymore, right? And just keep it in mind, right? Look, in GMAT, they say that each question is independent of the other question. So you do not need data from the previous question to solve the next question, of course. But for example, what in case it comes in handy to reduce your calculations or whatever, just keep this in mind that the number of people surveyed is at least 2500, right? So I got my answer as 2500. Now, I use the options to solve it over here, right? Now, one question could be, all right, what if, I don't have, I mean, of course, in a GMAT question, I would have options, but what in case I need to find this number for another question? And obviously, if it's a different question, if this is not what it's asking, then the options will not give me these values. They will not give me values of the minimum number of people, right? So essentially what I'm saying is, what if I didn't have the options to use? What if I had to myself figure out what is the minimum number of people surveyed? And now this is the tricky part of the question. Yeah, after this, everything becomes really simple. Okay. So I'll start with this one. This has to be, first I have to ensure that here everything is an integer, because coming from here to here is going to be far harder, right? I'll say 100, no. 625, no. 1000, no. I mean, I'll have to first find the 8% of this, and then I'll have to come here and see whether these values work. Instead, I'll go the other way around, because once these values work, accordingly, I can find what works for this particular graph. Yeah? Okay, so look at the values that I have. I have 10, 24, 12, 8, 32, and 14. So one thing that I notice is there's no prime number here, right? And everything is even, right? So then, all right, let me say 14%. I'm picking up 14%. What is the minimum value that I should have over here such that what I get over here is an integer? Yeah. So I'm going to say 14 is nothing but 2 into 7. I'm talking factors here. Yeah, we should be comfortable with that. And 100 is nothing but 5 into 5 into 2 into 2. So my 1, 2 gets cancelled off. Great. Yeah. But what about this 25 into 2, the 50 that is still here? 7 cannot cancel it off. If I want an integer over here, in case I want an integer, then over here I need to have at least a 5 into 5 into 2. Does that make sense? Yeah, we'll just come to the question. Yeah, let's just finish it. Then Sal will look at your question as well. All right. So where were we? Yeah. So we said that this needs to be at least 5 into 5 into 2. Makes sense? So that the divisor goes away. So I say, all right, so this needs to be at least 50. Now, does this 50 work for all the other values? Since all the other values are even, so each one of these values will have this 2 to cancel off, right? Some values may have another 2. For example, 12%, it has 2 2's. So you need something even smaller than 50. But you anyway need 50 for 14%. So, that is your smallest that will work for this entire graph, right? Everything else is even as well. So each value has at least 1. So what I've got is that I have to have at least 50 people who say that they like indoor games. Makes sense? If I have 50 people, then everything becomes an integer. Yeah. Okay. Now, these 50 people or a multiple of 50, of course, any multiple of 50 will also work. Any positive multiple of 50 will also work. they will be 8% of the entire big circle of all the people who are surveyed. So then I'll say now that 8% of the entire, of the total, that needs to be 50, at least, or a multiple, right? Okay. So now what do look here? I get a 2, I get a 25. Are we good with this, right? This gets cancelled off. I need a 50 over here. And I need to, of course, cancel off this 25. How do I get this particular 50? What do I multiply over here? I'll have to multiply 25 into 25, right? This needs to be my total at least. Why? 125 will get cancelled off. And 2 into 25 will give me my 50. Does that make sense? I mean, just your regular equations, right? This is how my equations work. So essentially, I've put an x over here instead of making it x, then, taking it over there and dividing it, etc., etc. I mean, I can do the same thing. Look, don't get confused. This is just a simpler way, of doing it. I can put x over here. X will be what? 50 into 25 upon 2. This gets cancelled. You get a 25. It's just easier. I find it very difficult to use variables. Yeah, I mean, it's easier to see. Okay, so I have a 25 here. So I need to multiply by a 25 into 25. Essentially what I got over here as well, right? Okay, so then I get that I need not 100 now. I need at least 625. My 25 into 25 is 625. So I say I need at least 625 people to have taken the survey so that 8% of the 625 is 50. And then this everything becomes an integer. But when I say that my 625 needs to be the minimum number of people, this 625 should give me all integers over here also, right? It works with the 8%, no doubt about it. Does it work with everything else also? I have to ensure. Again, I'll go to my prime number, the easiest thing, right? Because it doesn't cancel off anything. And I have to ensure that this is taken care of as well. So I say, okay, 19% of this 625, is it going to give me an integer? No, it's not, right? Your 100 is actually what? It is 25 into 4, right? If I say 100 is 25, it's not getting cancelled off with 625 to give me an integer. Of course, I have a prime number here, it will not get cancelled off. This only cancels off the 25. What about the 4? There is no 4 over here. So what do I need? I need another 4 over here, right? Then this thing becomes what? 2500. So now I understand that the minimum number of people must have been 2500. Yeah. This is the trickiest part of the question. Otherwise, now the question is going to become extremely simple. But do you understand how we arrived at it? We start with the indoor games. We look for what is the minimum number that will make all this an integer. Yeah. Then we use that number to see what is the minimum number over here that will work with the 8%. 8% of that particular number will give me the 50. So I got my 625, but I do realize that 625 itself is not going to work for this one. So then I need to find that particular multiple of 625 that will work for all the values over here. And that I found by multiplying 625 by, that is how I got my 2500. Yeah.